Hello, this is Dimitris from Ajuna Network, and in this video we will see how the Ajuna SDK, the generated projects from the Ajuna SDK can be used within Unity. So we do have a running substrate node, as we can see here, and now we're going to move to Unity and see how this is being used within the Unity environment. We have already seen how to generate the SDK and how to generate the necessary DLLs to be used in Unity. These DLLs have to be imported in this plugins folder so that they can be used by Unity. So this is a very simple example. It is already uploaded in the substrate.net.basic Unity demo repo that you will find also in the description. And the main thing that it does, it is that we will start our, let's say, game, and we will be able to connect to the node and listen to get the block number. We will use two approaches, either polling or subscribing to changes. The graphic interface is nothing particular. It's just to showcase that it is possible to call the Ajuna, use the Ajuna SDK from within a Unity environment. So I'm just going to start the application, the game, to see how it works. So now the connection status is disconnected. I'm going to connect to the node, and when I connect the node, I will start listening to getting the number, the block number changes. And if we go to the polka.js, we see that it's the actual block number that is being shown in the Unity app. I'm going to disconnect now and stop the game. The whole, just a bit of background. The logic resides in these C# classes. If we open them, it opens a .NET solution, and let's have a quick look at it. So just a second. Yeah, it's here. So what you see here is that in principle, we have like three classes. The Unity main thread dispatcher is not relevant. It's just used for synchronizing the different the UI thread with the background threads. So what is of interest for us in this particular context is the network manager, where the network manager is responsible for creating our substrate client that is going to be used for our node connection and getting the block numbers. And what is interesting is in this connection scene controller, we can see here the on click button connect. What it does is that it connects to the node and then starts listening or getting the block numbers. I have used a flag in the code. It is called use subscription. If it is set to true, we actually subscribe to the storage changes regarding the block number, and we get notified whenever there is a change. Otherwise, we use the polling approach, where we poll every 3-4 seconds for the block number, for the new block number. So in principle, you can see here that we have two methods. The one is the query for block number, where, as we said, we get the block number and we poll. This is being actually triggered every time that the screen updates. It's not after a set amount of minutes. And the other one is the subscribe to storage changes, where we actually subscribe to the storage change and give a callback, which is this one, the callback number change. The callback number change is called every time that the number is being changed, and what it does, it is updating our block number text, which is like the text that is showing the block number in the UI. That's actually it. That's not really more to that. We can also, just to test it, we can also try the polling option. If I set this to false and I return to my Unity app, it now reloads the changes. So if I now start the application, the game, it did start. I am connecting and I'm having again the same result. As we said, this can be found in the substrate.net.basic Unity demo repo.